question says, identify the acid, base, conjugate acid, and conjugate base in each of the following reactions. So acids are going to donate protons, and bases are going to accept protons. And this is the Bronsted-Lowry theory of acids and bases. So if we look here, HF, okay, becomes F minus. So HF gives a proton, which is an H and a positive charge, okay, to the H2O. So the H2O becomes H3O plus. So HF loses a proton, so it acts as an acid. This makes F minus the conjugate base. Why is it the conjugate base? Because now F minus wants to gain a proton from H3O plus, acting like a base to drive the reaction in the reverse direction. If HF lost a proton or gave a proton to H2O, H2O accepted a proton. This makes H2O, in this case, the base. Notice that H2O can be both an acid and a base, so amphoteric. So basically, in this case, it's acting as a base because it's gaining a proton from HF, and H3O plus is the conjugate acid. So a couple things to remember. Acids have conjugate bases. Acids donate protons. Bases have conjugate acids. Bases accept protons. The conjugate acid is after the base gains a proton. Now this H3O plus wants to give a proton to F minus to drive the reaction in the reverse direction. Said another way, it wants to act like an acid because now it's donating a proton to F minus as opposed to accepting a proton from HF. And conjugate bases are the same thing. F minus, HF lost the proton, but now F minus wants to gain a proton from the H3O plus to drive the reaction in the reverse direction. So acids have conjugate bases, bases have conjugate acids. Let's look at this next one. We have CH3, CH2, NH2. This is called ethylamine, and we have it interacting with water. If you notice, at the end, we have CH3, CH2, NH3 plus. So this gained a proton and a plus charge because protons are positively charged. So it gained the H plus. So this acted as a base. This is the conjugate acid of the ethylamine base. What did water do here? Well, water gave the proton to this to make it NH3 plus from NH2. So this acted as an acid, and the OH minus is the conjugate base of the water acids.